This experiment is about Archimedes' principle. Archimedes' principle is fundamental of fluid mechanics. When an object immersed in a fluid, it is buoyed up by an upward force from fluid. Pressure difference between the upper and bottom part of the object causes buoyancy. Pressure of fluid is increased by depth as shown in formula above. Therefore, pressure of object in upper part is smaller than bottom part. Archimedes' principle states that buoyancy is equal to the weight of fluid displaced. The weight is gravitational acceleration multiplied by mass of fluid displaced. And mass equal to density multiplied by volume. The final equation is shown above. The volume of fluid displaced is equal to volume of object. The object is fully immersed in fluid. In this experiment, we use this method to measure the volume of irregular shape object. Archimedes' principle is used to design the shape of a ship. The weight of displaced fluid is larger than weight of ship. Therefore, the ship can float on water. These are 3D printing objects used in this experiment. Here is the demonstration of Tinkercad. Use cube as main object. Use torus as the hang of main object. Change the dimension as needed. You may either save in OBJ or STL file. The experiment uses cubes with same volume but different density, which can be modified by changing 3D printing setting. Infill percentage is one of the settings of 3D printing and changes amount of material filled in solid. We can print different density cube by changing infill percentage. Measure the weight of object. Prepare a cup of water and measure its weight. Total submerge the object in water and hang it by metal wire. Record the present weight. Subtract the measured weight with weight of cup of water. Repeat experiment with different object.